You're welcome to Reservation Mathematics Institute. In this short video, we'll be talking about introduction to numerical analysis. Numerical analysis is the branch of mathematics that deals with the study of a problem that can be solved analytically and some problems that cannot be solved analytically with the basis of obtaining a solution to those problems. Though we have problems with the right solutions, but this purpose is to introduce a method called the numerical method. To solve such problems. And the basic characteristics of numerical analysis, let's look into the basics. We have the problem, we have the solution. Okay, this is the original problem, being the problem that is to be solved, and the solution is the solution obtained, the result obtained from the problem. But we have said in the concept of algorithm that there is something between the problem and the solution, which is the method that involves an algorithm. Good. From this, we have an exact solution when it comes to an analytical problem, and the purpose of this analysis is to introduce a new method called the numerical method to solve the same problem that can be solved analytically with the use of a numerical method to provide and produce an alternative solution, being an approximate solution to the problem. And from this solution, we have the third phase to be an approximate solution. And the fourth thing here is the error. And from the error now, we have the convergence. So those are the things you must understand when it comes to numerical analysis. And over this, we have to transform this to a concrete way so that everybody will be able to understand what you are talking about. This is just the abstract. This is the abstract. This is the abstract nature. When we are comparing the abstract nature with the concrete aspect, let's look into that. Let's take, for example, my bracelet. The problem is you need a bracelet. You need a bracelet. The solution is Michael Kors design. And you are looking for another bracelet that is similar to Michael Kors design, because the Michael Kors design is not available in the market. So you have to look for an approximate solution to Michael Kors design, which you have gone through another designer that you want to make something like this. So after the production, you come up with let's say Jordan design. That is your result. The Jordan design that is very, very, very close to Michael Kors design. So by the time you are looking at the fourth leg, which is the error, you compare each of the part of the bracelet of Michael Kors with what the designer Jordan has done. By the time you begin to look at each point, this is a particular point, you compare it. You look at the second point, you compare it. You look at every part so that you have a comparison of what Michael Kors has given and what your designer Jordan has done. So by the time you bring the two together, are they the same? Will people know that what I'm using is Michael Kors? Nobody will be able to tell you that this is not a Michael Kors because it has been done the way Michael Kors has done it. So that leads us to what? Convergence. Because it is very close to what Michael Kors has done. What Michael Kors has been done by a Jordan designer. So this has an error. It could be a small thing that differentiated Michael Kors from Jordan, but it's still acceptable. Nobody will be able to see that because it looks exactly like Michael Kors. So that leads to convergence because it is acceptable. So far it is acceptable and it is very close to what has been done and what you have given the designer to do. That means it converges to the solution of Michael Kors.